Right, so today we want to take a good look at how to graph linear inequalities and choosing a single region that satisfies all the underlying inequalities. So we take example 1. On this board, we see show a single region which satisfies y is less than or equal 3x minus 1, 3y minus 6x greater than or equal to 6, and the non-negativity x greater than 0, y greater than 0. So there are 3 ways to graph a line. So what happens is we are going to graph them at their boundaries. The boundary equation here is y equals 3x minus 1. The boundary equation here is 3y minus 6x equals 6. Of course, the boundary equations for these two, x equals 0 and y equals 0, I will explain that one when I want to graph them. So we can graph using slope intercept, we can graph using intercept, we can graph using a table of values where we assume values of x and find their corresponding y values. So I will vary the methods. Like in the first one, I will graph with slope intercept. So my slope here is 3/1. Slope is the coefficient of x. That means I will rise by 3 and run by 1. When I come here, I will try and use another method, the intercept, where I look at the y-intercept, x is 0, x-intercept, y is 0. So when x is 0, I put x 0 here. I have 3y equals 6, which means my y here is 2. Now when x is 0, when y now is 0, the whole of this goes to 0. Negative 6x goes to 6, then x is negative 1. So I have the 2 points, 0 and 2, negative 1 and 0. So right away, I can draw these lines. Then I'll look for that region to shade. The region to shade comes from the given sign of the inequality. But there is a key note here, that anytime the coefficient of y that you see in the equation is negative, we have to switch the sign. So the coefficient here is positive 1, or it's just y, so that is fine. So because it's less than or equal to, the solution to this line will be below the line. The coefficient of y here is 3, which is positive, so we don't switch this sign. This sign is greater than or equal to. So the solution to this line, if I graph it, will be above the line. I need to grab the line. I'll grab the lines here. Two, 4, 6, and 8. Negative 2, negative 4, negative 6, and negative 8. 2, 4, 6, and 8 here also. I can put negative 2, negative 4. Negative 6 keeps going. So if I want to grab the first line using the slope intercept, I will always start from the intercept. The slope is 3/1. My intercept here is c is negative 1. So I have to go to the y-intercept negative 1 somewhere here. If this is negative 2, I say half is negative 1. I'm not drawing to scales, or we try and then fit ourselves there. Negative 1 right here. Then I need to rise, go up by 3. 1, 2, 3. I come here and run by just 1. If this is 2, 1 is somewhere here. So 1, 2, 3, and 1. This is the second point. From the y-intercept, then I can draw my line. So this is line 1. Y is less than 3x minus 1. Because it's less than, the solution to this is below the line. Let's grab the second line. We have the 2 points already. 1 point is 0 and 2 right here. The next point is negative 1. Negative 1 also here. Negative 1 and 0 here. So when I have this and this, I can draw my line. I'll draw my line, and because the inequality here, the sign of the inequality is greater than or less than, I have to be above that line always. Above this line, above this line, above this line, above this line, above this line. Don't forget, we still have to be below this line, the first line. So I'll graph these two simple equations. It says x should always be greater than 0. This is the line x. This is y. If x is greater than 0, we are always here. So x greater than 0 is here. It means anything here, we are greater than 0 on x. So we call this line x greater than 0. If y greater than 0, it means on the y-axis, everything here is positive or greater than 0. This is the line. Now I'm going to look for the single region that will satisfy. So this is my y greater than 0. So this is me graphing all the 4 lines, and now I have to choose one region that will satisfy all the 4 conditions here. I have to be bigger than 0 for y, so I can really be here or here. I cannot come here, because anyone that comes here is y, the y value here will be less than 0. Anyone that come here, the x value will be less than 0, and the x must be greater than 0. So this is not part, so we have to stay here. Now I have to be below this line, below this line. If I have to be below this line, what that meant is anything above that line is false. So I can only be here, here. But between this and this, I still have to be above this line. So the only region that will satisfy all the 4 conditions is this small region here. I'll put the arrow here. We call this region the feasible region, R. That single region that satisfies all our 4 constraints or inequalities. I'll take another example so we can get the concept. This time it says we show the single region which satisfies these 4 conditions again. I have negative y less than or equal to negative 1. So my boundary here is negative y equal x minus 1. I can use any of the 3 methods. I can use intercept, slope, intercept, or table of values. I'll use intercept here. If x is 0, this is 0. So negative y is negative 1, then y is just 1. If y is also 0, this is 0. 0 is equal to x minus 1. I take this one here, x equal 1. So I have the 2 points, 0 and 1, 1 and 0. I will grab the second line, 5y. I'm just staying with intercept because it's quite faster to solve. Minus 10 x, greater than or equal to 0. When x is 0, the whole of this goes to 0. 5y equals 20. My y is 4. When y equals 0, the whole of this is 0. Negative 10x is 20. Then x is negative 2. So I have the points 0 and 4, negative 2 and 0. Right away, I can draw the 2 lines. 2, 4, 6, and 8. 2, 4, 6, and 8. 2, 4, 6, and 8. 3, 4, 6, and 8. So the first one has 0, 1, and 1, 0. 0 and 1 is here, 1, 0 is somewhere here. Where is the solution to this line? I go and check the sign. It's less than or equal to. But because y has a negative coefficient, negative y means there's negative 1 times y. So because the coefficient of y is negative, I need to switch this sign. So I'm not going to shade less than or equal to, but I will shade greater than. I need to flip the sign, so I will shade above that line because the coefficient of y is negative. When I take the second line, I have x is 0, y is 4. 0 and 4 right here. And then x is negative 2, y is 0 right here. Then I'll draw. The coefficient of y is positive, so I keep the sign greater than. It says x must always be greater than 0. This is x greater than 0 is here. So we are here. Y greater than 0 is this region up. Y greater than 0. So I need one region that will be above this line, and keep these conditions. So these conditions of y greater than 0 and x greater than 0 means we can never come here. We are staying in this space. So we can meet these two conditions. Now between these two regions, because I have to be above this line, I cannot come here. Because I have to be above this line. And also above this line. So the only space that satisfies our condition is here. Any one that stays here is above this line. It's also above this line. Meet our x greater than 0 and meet our y greater than 0. So this is that region. This is how we graph inequalities. Subscribe to the channel. Let's continue to make maths beautiful. Thank you.